This example is going to look at an application to exponential functions. In particular, it's going to look at compound interest. So to start, our formula for compound interest, we use A, being the amount in the account after a certain amount of time, is equal to P, which is the principal or the amount invested, times 1 plus that rate divided by N, N being the number of times that it will compound, raised to N times T. I want to note here that R is going to be written in decimal form. So looking at our example, we have an investment of $8,000 and it's invested in an account with an annual interest rate of 6%, and the 6% is compounded monthly. And this is what tells us that we know that we're going to be dealing with compound interest. What we're asked then is how long will it take for the account value to reach 10,000? So from here, let's identify, we have our main formula, and what we're given then, we see this 8,000. So we're given that P is 8,000. And we're given that R is 0.06 based on that 6%. And this compounded monthly, that means that it compounds 12 times a year. So N is going to be 12. All right, now as far as the question that we're asked how long. So we can see from this question that it's saying find T. And it's giving us the output of 10,000 there. So it's telling us then that A will be 10,000. Okay, so to start, let's write our main formula. So the general formula for this is going to be A equals 8,000 times 1 plus 0.06 divided by 12 raised to the 12 times T. Okay, so we can see that what's unknown is T and also A in that equation there. So in this case, we're given A and we're going to need to solve for T. So we'll input then, we'll set up that equation with 10,000. That's the output that we're given. We'll input that into that equation. And that's going to equal then our 8,000 times this 1 plus 0.06 divided by 12 raised to the 12t. Now with this equation, that variable is given in our exponents. We're going to need to use logarithms to solve it. And to do so, we're going to first want to isolate the part of this expression on the right-hand side that contains that variable in the exponent. So we're going to want to divide each side by that 8,000 as our first step. So we'll have 10,000 divided by 8,000 on the left-hand side. And on that right-hand side, we'll have that 1 plus 0.06 divided by 12, all raised to the 12t. Now, in a lot of problems, we won't be able to simplify something to an exact decimal. In this particular one, we can. In this example, that left-hand side simplifies down to 1.25. And this 0.06 divided by 12 is 0.005. So I will write this in decimal, but only because I can do it in an exact way in this problem. Okay, so now we have that equation. It's an exponential equation. Our variables and our exponent. So we'll want to use logarithms to solve it. And we can either use log base e or log base 10. As we don't have an exponential expression with either base e or base 10, it won't matter which one we use. So I'll use log base 10 in this case, just by choice. So I'll have log of 1.25, and then we'll equal log of this 1.005 raised to the 12t. So all that I did there is apply that log base 10 function to each side of the equation. And what that will do then is, because I've applied that log function to the right-hand side, now this variable that was in the exponent is going to come out front as a coefficient. So that right-hand side will now be 12t times log of that 1.005. And that left-hand side is log of 1.25 still. Okay, so not too bad. At this point, this equation is just linear. So what I have left is I just need to divide each side by 12 and by log of 1.005. So doing so, this left-hand side will be log of 1.25 divided by 12 times log of 1.005. And the right-hand side will just be t when I divide it by 12 and by log of 1.005. So if I approximate that, and that's something I do in my calculator, I'd get that t is approximately 3.73. So looking at what that means in the context of this problem, I can now answer that question. The question was, how long will it take for the account value to reach $10,000? So I'll state that after about 3.73 years, the value will be $10,000.